Hello, in this video, we introduce our study diagnosing motion-specific quadrotor battery health through a high-fidelity battery model. Since quadrotors are systems strongly constrained by battery performance, there are many battery-aware quadrotor studies. However, in their works, they only used low-accurate simplified battery model and only considered average battery use, except transient effects. Here, we propose a study for analyzing quadrotor motion-specific transient effects to battery degradation through highly advanced battery models. Specifically, we begin with reference performance test for target battery packs, and then calibrate the model using the reference test result. In parallel, we collect flight data in real quadrotor experiments, and finally assess battery health through virtual experiments using the calibrated model and measured flight data. First, we design the reference test to cover both steady and transient state of batteries using a custom battery-in-the-loop system. Then, using the reference data, we calibrate the battery model. The results indicate the model are calibrated with a tolerable error. In parallel, we mount a custom current sensing module on the quadrotor and record battery current during flight. We sample at 10 Hz and we collect horizontal, hover, and vertical maneuvers. Here's the raw current from the log. We can select 3 segments: horizontal, hover, and vertical. Then, we periodically reconstruct these 3 segments into standardized waveforms for a repetitive replay. This slide shows results of the virtual experiment for the vertical motion, including general outputs such as energy consumption and temperature. Further, the results also include degradation information, so we can analyze detailed degradation impacts. Here is the degradation analysis result. First, all motions cause fluctuations that induce extra microcrack formation. Second, only vertical motion triggers severe particle cracking, leading to active material loss due to large amplitude peaks and high stress. In conclusion, motion-specific loads drive degradation differently from average energy use, mainly through transient current features. This highlights the need for motion-aware battery management in future applications. Thanks for watching. More results are in the paper.